we're back working on the Jose 50 watt head. As always, brought to you by 3 Monkeys Solderless. Home of the world's best cables for your metal board. 1/4 inch DC audio for your car stereo and for your home stereo. So you got like a component tube amp, receivers. You have a turntable in there. Got your head unit. Got your power amp in your trunk. Where are you going to find it? 3monkeyssolderless.com. All right. So where we last off was doing some of the pot work and all the jacks. This here thingy, whatever you call that, I don't know. Does has something to do with making the amp noisier, I think. All right, so what I thought we'd do right now is do some shielded cable work. Get this preamp sort of solder strip, red tag strip, ready to go with the preamp on there. What we can do, we'll drop the board in and we'll see what we got for time. We're trying to keep these videos somewhere reasonably long so that they don't overheat my internet connection and make it too long to watch. All right, so let's start. So first thing I'm gonna do, and obviously I still have my hand taped up for the nerve damage, which is fine. We're gonna attach this solder lug to the base pot, right over here. All right, and that is going to help us install our shielded cable and ground it at that potentiometer. So I like to use these to keep everything where I want them. So I'm gonna just kind of grab it. That looks good. This one's being a little non-cooperative. Not getting hot quite as fast as we want. Maybe the soldering iron hasn't quite warmed up to temperature yet. I think we're getting, yeah, the soldering iron wasn't hot yet. Here we go. All right, so now we have our little tag there that we can attach our shielded cables to, and that gives it a nice place to get grounded, where the shield can get grounded. So let's start with that. These are the leads that are going over to the cathode follower. So we're gonna need about that much extra. Right, so you have your shield. And what I like to do is take my here pokey tool and kind of splay out the shield to a point and just nip it off. And then I could solder it in place. So it's kind of a, it's not my favorite part of building amplifiers, dealing with this stuff. It's kind of like untangling dog hair or cat hair, or taking chewing gum out of someone's hair. It's just not fun. It's a lot of tangly stuff and yanking on things, and I just don't particularly love it. Cut a little bit more off it, give it a little trim, makes it a little easier to go. All right, now I'm gonna get to leave myself not that much, about, you know, 3/8 of wire, of rather shield still on. Trim off the excess. Then what I basically will do is I'll just flatten it out. Create a little bit of a disc there, right? And then I can apply some solder to it. Then I can run it through here. Then I can connect where it needs to be connected. should be on this here lug. I think this has a little extra solder on the end of it. We need to take off because there we go. Was not going through the lug easily. There we go. Go ahead and that's good. And we can kind of figure out how much we need. Can bring it down to here and leave it. Now we're gonna run the next piece of, something fall in here? Yes, get that out of there. I'm gonna run the next piece of shielded cable from the same general vicinity. Why is this driving me nuts? You know what, let's just cut this off. There we go. It's probably gonna end up using what's left of our shielded cable. So we're gonna need, once again, to cut off just about the same amount of our insulation, and once again, peel back the braid. Like I said, not my favorite part of the game. It seems to take an awful long time to work with certain cables the way I like to do things anyway. I like things to be really neat and secure. So, you know, other people may just, I don't know, have simpler ways of doing this, but this way is proven to me to be very reliable for keeping wires where you need them to stay, for making good ground connections, and for things not to break. So that is the whole raison d'etre for my existence, as they say. Reason for my existence. Reason for being. Reason for being so is to make things better than a machine would that's being operated by a person who likes to count beans, right? A machine bean counter. So, you know, I think a lot of people get into trouble chasing the next quarter. I think we've seen that with a bunch of our favorite companies over the years. Right? Companies that were legends in the industry, still are legends in the industry, that, you know, really started everything in a way. These companies, we know who they are. They will remain nameless at this point. But in the never-ending quest for what the corporate world likes to call growth, that they could show their investors as well as their board members in the search of a large market capitalization, will often make decisions that over time will destroy everything that they worked for to become and do. So I think we've seen that happen too many times. So basically I'm getting these things where I want them. I'm going to solder them now, like so. Now they are firm, stuck, not going anywhere, and grounded to our ground bus, our pots, and that makes them very happy. Those grounds are now very happy because they don't have a lot of AC dumped on them that might piss them off and make them noisy. It also makes them very happy because they don't go anywhere. They're nice and secure. Right? So that also prevents any pulling at these solder points here and here, right? Because you can yank on this all you want. It's not going to get to here. So that's kind of what we're looking for. And then these things can be run along the back here. And then up to around here. So these are ready now. All right, so we could grab just a couple of zip ties and we can kind of zip tie them together. And I like to also just make one of them easier to identify. So the front one, I'm going to take a little bit of insulation off. So now I know when they come out the other side very easily which is which. I think we have one that's already kind of like that. So we can take this one and lasso it. That's got to be the other way. Got to make them look all the same. Lasso it. Yeah, that's right. Need a few more of the wire ties. Trying to find where I put the giant bag of wire ties at. Oh, right here on the bench where they belong. Put them in the wire tire glass. Lasso. All right, that should be good. And we'll just kind of lay it down back here where we can't see it, which is nice. Oh, you know what we didn't put in is the presents pot. So let's do that. So we have our 25K presents, which goes back here. And we can put on our super duper lock washer, which I like better than the stock lock washer. Get it in place. Right, make sure that nothing's in its way here, which would be these output transformer secondaries. Kind of get that out of the way. There we go. That's nice. Let's see if I can grab this. Nice and tight. Everything's free and clear. Everything looks good. Okay, so we need our reference or ground reference resistor. Over here, rather. And that will come around to the front. So I could take a little bit of that off. And I can solder our ground reference. All right, so this is the more, how should I say it? The later present circuit that you would find in late 60s and then throughout the rest of sort of the Marshall sort of history. And reason for this being is that they wanted to eliminate the scratchiness of the presence pot, which was due to DC, right, which is voltage, traveling across the pot and varying when this pot was turned, which would create, because the DC reference would be coming from the cathode resistor, right? The cathode, the cathode of the long tail pair of the phase inverter would be grounded through this potentiometer, and when you changed it, you would get a variable sort of ground. So this resistor on the side of it, a 4K7, which was an approximation of the 5K pot that they used to use as opposed to the 25K pot that they now use, would create a constant, near constant ground reference, which wouldn't be terribly variable, which, although does not completely eliminate said noise, does do something for shutting it up. All right, so now we're going to put our capacitor here. All right, so I'm going to need to bend these guys. There we go. And we'll be using a 0.68 capacitor there, as opposed to the 0.1s, which would have been used like in the JTM 45s, like the last build. When we built that blues breaker, that never existed sort of amplifier, which we're probably going to get some more clips of. So there we go. So we got the presence pod in, we got that ready to go. We got our shielded cable here. Okay, so let's continue on. Trying to think. All right, so yeah, that looks like the way we're going to do it. All right, so I have, the first thing I'm going to do here is I'm going to put in, you know what, let's do our cathode first. I'm going to grab another 0.68, which is the cathode resistor that we're going to use there. I mean, cathode capacitor. It's hard to talk and video at the same time. And then we're going to need a 2K7. Resistor, right, because that's our cathode resistor. Then we're going to make a little network here out of the two. All right, run them in parallel. So you're going to wind one around the other. Like so. Trim off the excess. Solder it on. Fold them over, and then they'll just basically go right here from the outer lug to the ground lug on this solder strip, tag strip right here, right? So I'm going to kind of just wind it around. Just like that. Solder this side on the top. Very good. Now we can just run our, get some wire, some yellow, because I think that's what we're using for cathodes. Let's grab some yellow wire. that to the cathode on the tube socket. That's good. All right, and then we can connect our plate resistor, which would be a 200K. Get that. Should have all this stuff out beforehand. Unfortunately, I did not. So we got our 200K. Right, we're going to run that from this outer lug to here. So we're going to need a little bitty bit of insulation. We'll use some red to kind of cover up our leads here to insulate them like that. Just give us a little trim. Pre-tin it. Okay. Put on our next piece of insulation here. Then we could just run that through the tab on the 9-pin for the plate, pin 1. Make sure that is exactly where I want it. There we go. Okay, now we got it. Tell you, it's hard to work with this big lump on my finger because I can't, which is a good thing I can't feel what it's doing. It's also a bad thing because I can't feel what it's doing. Okay, so we got these right there. All right, so the next thing we're gonna do, I just wanna make this neat. There we go. Is we're gonna take the lead off of there. Let me get my capacitor. So I have my capacitor here that we're using for the coupling capacitor on the amplifier. So we can use some white lead for that. It looks like we're just going to need, let me just make sure that this is good enough to get over this. Yeah, there we go. That's fine. Pre-tin it, and we'll get our capacitor in there. Right, so that's the output, so to speak, of the tube stage. Grab our next piece of insulation. Wait, that's not our piece of insulation. This one is. There we go. And then we can trim a little bit off of it just to make our life easier. Drop our plier or wire cutters on the floor to make our life more difficult for a second. Thread that through, get it up over the top. bend it into place. Now we can solder pin 1. There you go. Then we can clean it up a little bit. There we go. We need to take that, trim it. Okay, so now that's in a good place. This is in a good place. Let's clean it up a little bit more. There we go. Get those two together. All right, so the next thing we're going to do is we're going to run our, you get the value of that. Yep. All right, so we're going to run our treble bleed from the output of this stage to kind of darken it up, create the tone sort of shaping that we're looking for. Just kind of twist it around these two leads from the coupling capacitor over to the ground. And we're just going to crimp that in place. That looks good. Solder at home. This one we could do a little bit of soldering. We don't have to do just to hold it, like a placeholder. So we're actually going to be putting some shielded cable through there. All right, so that is ready to go. Now to finish this off, all we're really going to need to do is to bring, that's soldered, is it? Let me check. No, got to solder this connection. May have been soldered, but I wasn't entirely sure, so we're going to do it again, and then we know it's soldered. All right, so we just need to bring our power supply from the B plus to right here. And our shielded cable runs from the input jack and up to the gain potentiometer. Also have this capacitor, which is our bright capacitor for the volume pot on the bright channel. So we might as well put that in now before we lose it. We just wind it around here. There we go. And we can give it a tiny little bit of a placeholder soldering, or it's just a little bit like that, which still allows a lead to kind of pass through there, but at the same time will prevent this really from going anywhere. So you can kind of keep it out of the way, but not lose it. All right, so let's get this piece of insulation out of there. See where we're at. I think we can do our leads from here to here. So we could do our input lead, right, which would be from the lead jack over to the grid here. So we could start basically by stripping a little bit of the shielded cable again, right? And we're gonna do the same thing as before. Kind of remove, peeling off, unbraiding some of the braided shield, right? And if you're, I'm using a Teflon, a German wire, Tefzel. Right? Teflon is actually a trademark name. I think DuPont has, or had the, I think the name Teflon. So, you know, use the chemical name for it when they're selling it. And the German wire that I like is just called Tefzel. And it's, you know, aviation wire, basically. You can get it from avionics supply companies. It's used a lot in airplanes. It's very good. So then once again, we're going to kind of give ourselves our little solder blob area here that we can just put a bunch of solder on. Right, and it just soaks it up. And then we can kind of run it through. Is this going to be the bottom or the top? It's going to be the bottom. All right, so this is going to be for the grid. So we're going to push it through the bottom here. Right, like that. There we go. Like that. Let me get this lead out this way so that we can see it. And then all I'm going to do is pretty much tin this lug here pretty hard and then shove this in from the other side. All right, it's going to have a lot of tinning on it. And the Teflon coated wire will not melt while I'm doing this, which is the beauty of the Teflon. So I can come from the other side and kind of work it there and work it there. And now we have it soldered in place. Just going to clean that up. See, now that's soldered to this center lug, which is connected to the chassis. So that's our ground for the shield there. Now I'm just going to strip a bit of this lead here of the core. Right, the core is what carries the signal. The shield is what shields the core from the RF everywhere that's in the amp, and it's most critical in the early stages of a higher gain amplifier to have as little noise as you can get. Right, you can't eliminate, I think we've talked about it, you can't eliminate all noise. So there's some, confusion, I think, about what noise is normal and what noise is not normal. What you can avoid through a good build and what you cannot avoid no matter what you do, pretty much, within reason. So the things that you can avoid are things like buzz, which bzzz, hum, those are things, and squealing, high frequency noises like feedback, or low frequency noises that are feedback. And that all has to do with either poor grounding of your shield, right, that you're grounding it someplace that's dirty, so the shield is going to pick up noise, or it's unshielded at all and your grid wires is picking up all kinds of RF, right, which could be positive to the signal or negative to the signal. If it's positive to the signal, you're going to hear basically at that frequency a feedback, which will then sort of grow, and that will make the amplifier squeal and be completely unusable. I don't want to cut that. See, I'm talking and I don't need to be talking. What I need to be doing is just kind of, right? So I've unbraided this and I'm wrapping it around here. I'm going to put a bit of heat shrink over that to hold it all in place. We'll get back to the noise again in a second, but I just want to show this. So that goes over it, right? And that holds the shield away from the core, so you can't ground it out. And then the heat shrink will make sure it's all secure and kept in place. Okay, so back to the hum. All right, so if you have a positive sort of RF coupling, you'll get something like a feedback loop where the amplifier will, on its own, start creating a very loud noise of a certain frequency, either very high like a very loud whistle or a very low rumble like a motorboat. And that's called motorboating or oscillation, whatever you want to sort of like, whatever term you prefer. Motorboating is generally more fun than oscillating, I guess. More fun term, but it has to do with the sound mostly. That the lower frequency oscillations in guitar amps we refer to as motorboating. Higher frequencies are turned to oscillation, but they're both forms of oscillation or positive feedback. Okay, so that's positive feedback. That can be avoided by shielding the cables that could possibly talk to one another and prevent them from that. The other thing that can happen is you could get negative feedback, right? So there's going to be a signal that's out of phase with the signal with the wire. So this wire unshielded next to another wire that's carrying a signal that's out of phase with the signal on this wire. What happens then is more insidious, in my estimation, in some cases. Sometimes you want something like a little bit of that kind of a coupling to reduce, let's say, make the amp very stable, reduce the possibility of the amplifier going into oscillation. Improve, in some cases, you would use it to improve the tone of the amplifier, right? To clean it up, to make it more focused. But if it's too much, you're not going to notice it because it's not glaringly obvious like when the amplifier is oscillating. It's just not going to sound very good. So to me, that's more insidious. That it's like, why does my amp sound not great? And you may not even know that your amp is sort of suffering from this disease. It's a hidden disease. It's sometimes called parasitic, right? So you don't see it. It's inside. You would need a scope to look at it. You would need to sort of do a little bit of thinking with your thinking cap on, like where is our RF? What's coupling with what? Is this good? Is this bad? So that's sort of like the issue with noise. And shielded cable can allow you, as well as good grounding practices, to avoid a lot of the messes of, let's say bad wire routing, or your sort of the way that you laid out your design, if it's an original design, isn't very good, with a lot of stages kind of, flopping over each other or out of order in a direction. Like you might have 1, 2, 5, 4, that kind of stuff. That doesn't make any sense. So there's a little bit of a science to it. There's a little bit of an art to it. There's a little bit of a benefit from it, and there's a bunch of negative from it. So that's noise. Now the noise that you can't avoid is like shot noise or thermal noise, and that's the kind of shh sound. And the more you turn up earlier gain stages, the more shh you're going to get. Now that has to do with the way that the tube is working, and electrons are always flying from the different elements inside the tube to create the signal that is then modulated by the guitar signal to create your sound. If you don't have shh, you don't get anything. So the shh is always going to be there. That is the lack of signal. That's like static on the television. You cannot remove static from a television that's using a broadcast antenna to search the airwaves for a frequency. If there's no frequency that's going to overwhelm just the general noise of the universe, then you're going to see static. Like on a radio too, right? Radios, you hear static. If you're not tuned to a station that can kind of get above the static, you're going to hear the static. And the static is all the noise from all kinds of crap flying around the world, right? From the sun, from God knows what. So that's interesting stuff to me. Maybe a little too much pink drink. Let's see where we are with time. We're at 39. So let's run one more cable, and I think we can probably call it a day. So we're going to run our output cable here, so to speak. So we stripped another, basically almost every time the same amount. Right, and we're going to do the same thing again. We're going to take out some of this insulation, or not insulation, some of this shielding. Tell you, if I could ever keep words straight in my mouth while I'm talking, that would be something. That's who I am. All right, that's enough that we can just kind of cut this off and have less matted hair to fight with. So we finally did win the classical music lottery again. It's a little bit of Mozart for us. My favorite. I don't know why. It just is. Everybody likes something different. So now we're going to go once again through this center terminal, but through the upper one. All right, and then we can just go ahead and solder that guy. Now that is in place as well. So we can fold it back down with this other cable and bring it up, bring it to the back, right, like that, and then bring it up to this potentiometer right there. Good. I think we're going to have enough shielded cable to get through this. I'm going to have to order some more Tifsel very soon for the next build, the next Jose. But it's been months since I've built one of these. I got to do some, I'm waiting on some marshmallow, the one parts as always. So, you know, you got to kind of build what you got, what you can. So the one parts, there's a few that I'm still waiting on to get onto the next builds. But there's still a few that I'm getting to. So that will be done. Get our heat shrink on there. There we go. Very nice. All right, so I think, where are we at? 44 minutes. So I think this is a good place to start, or stop, not start, stop. And what's left to do? Oh, let me clean up this bench a tiny bit. Well, we can put this guy in. All right, so what's left to do is not a whole lot. You just have to put the board in and finish up the final bits and pieces of shielding. These different cables, runs. Push this through here. This is our jump switch. So that just goes right like that. Get our nut. Need our nut holder. It's this one. Yeah. Actually, it's a smaller one than that. That ain't it. Where is it? Where'd it go? Where's my other nut driver? Ah. Yeah, that's it. Okay. Jump switch. All right, so I think this is definitely a good place to leave it up. Next time we're going to put in the board, finish up the shielded cable, run the filament lines in, and then I think it would be time to turn it on, test it, and start burning it in. So we're getting close to the finish line here. Stick around, more to come. Thanks for watching. See you next time.